Okay. 2.5 zeros of polynomial functions. What are zeros? Solutions, keep going. X-intercepts. Roots. So those are the three things. All right. So if f of x is a polynomial of degree n, where n is greater than 0, then f has at least one 0 in the complex number system. If your power of your x, so we're just going to use the variable x. If your power is 0, anything to the 0 power is what?
0.
Nope. 1. So it'll take that letter away or the variable away. So that's why it says n has to be greater than 0. So your power has to be bigger than that. If we just have x, we can set x equal to 0 and our answer would be 0. Does everybody understand that? So a power of 1 was going to give us 1. A power of 2, remember I've talked about, gives you 2 zeros. We're going to keep going. Linear factorization theorem. If f of x is a polynomial of degree n, again, it has to be greater than 0, so it actually has a variable in it. Then f of x has precisely n linear factors. I just told you that. If it's a squared, it's going to have 2 factors, or 2 zeros, 2 solutions, because they come from the factors. If it has 3, it's going to have 3, 4, 4, so on and so forth. So that means f of x, you're going to have a to the n, that's just your leading coefficient. You would have x minus c1 as a factor, x minus c2, until you get to that nth power of whatever it is. So all that's saying is those are multiple factors, where c1, c2, all the way up to cn are complex numbers. Basically, they're answers, numbers. Again, nothing that you don't already know. Determine the number of zeros of the polynomial function. So how many zeros, root solutions, answers will this one have? 4. So your degree equals 4. Your number of solutions, zeros, roots, x-intercepts, equals 4. Now, they're not all going to be, some of them, all of them will be real. They could be a combination of real and imaginary, all real, all imaginary. It just depends. Okay. So you will always have 4. That doesn't mean you'll always see them on the graph, because there may be some imaginary ones, and we'll talk about this. So the rational 0 test, if a polynomial f of x equals an of x to the n plus a to the n minus 1, x to the n minus 1. Remember, it's going minus 1 because we go in descending order. So 3, 2, 1, 0. This just means a is the coefficient of the first term, the coefficient of the next term, coefficient of the next term, so on and so forth. So don't get lost in the letters and stuff. It's just giving you a generalized form till we get to x to the 1 and then x to the 0. Has integer coefficients, then every rational 0 of f has the form rational 0 equals p over q. It's the worst q I've ever made in my life. Where p and q have no common factors other than 1. And then we're going to talk about what p and q equals. Again, you already know this. You already know this. So p is a factor of the constant term. A sub 0. And Q is a factor of the leading coefficient. And I'm going to explain this one because you do know it. You probably just don't realize that you do. Great. So P over Q, if we had something like x squared plus 4x plus 4. Factor that, what do we get? Factors of 4 that add to 4. And you would tell me that your solutions are what? -2 and -2. Remember when we have a fraction, what do we do with that fractional number? Yeah, put the bottom to the top. What's the number up here right now? So see, we can write it like this. Does everybody understand that? This P that's on top is a factor of the constant A sub 0. Remember, that's the end number. 2 and 2 are factors of 4. That's where it came from. Is everybody good? And then your Q on the bottom is factors of your leading coefficient. What's your factors of 1? 1 and 1. So you already knew that. Does everybody see that? So it's nothing any different than what you've already done. How do you solve set it equal to 0 or use the little cheater method where you change the sign? So there's nothing any different. All of that up there is stuff that you already know. They just have it in writing instead of in examples. All right, so find the rational zeros of x to the third plus x plus 1. So your leading coefficient is 1. What's a leading coefficient? The number in front of the highest power. Number in front of the highest power. A coefficient is a number in front of the variable in general, but the leading coefficient is going to be in the highest power. So possible zeros are factors of the constant. Which one is the constant? Look at all these terms. Which one? What is a constant? Louder. What's a constant? Yeah, it's the very last number without a variable. It's just a single number. All right, so this is how it's going to work. Tell me factors of positive 1. Tell me factors of positive 1. Those are not the only factors. Can you think of another set of factors? They are whole numbers. The other set of factors are whole numbers. -1 and -1. This is the only time that I'm really going to make you do this. You guys could factor it out, or you could look in your look on your graph to see where they're at. But this is telling you how to find the rational zeros the absolute longest way possible. Okay, absolute longest way possible. You don't have to do this in your homework. So you're going to take and plug in your factors. The good thing about this one is we only have 2 different factors. We have the positive 1 and the negative 1. Now, if you would have had 1 times 2 and 3 times 5 or something like that, you would have to plug in all 4. So we just have 2 different ones. So 1 and -1. So I'm going to plug in the 1. 1 cubed plus 1 plus 1. What is 1 cubed? Plus 1? Plus 1. 3. Then we're going to plug in f of -1. Plug it in. We get -1 cubed plus -1 plus -1. Now you can write -1, -1. I just want you to know that I plugged that in. What's -1 cubed? -1. Say it again. And then -1 again. Is that good? Whoever's got Snapchat, your phone should be up here, and if it's up here on Snapchat, might want to like silence it. So if you thought it was yours, fix it. This one has none. Let me tell you why it's none. All right, so it says find the rational zeros. This one has none because neither one of those that you've plugged in are equal to 0. Just by doing what are your factors of 1. So if we look at this, this is the absolute worst way to do this. Does everybody understand that? I do not expect you to do this in your homework. I'm going to show you right now. X to the third plus X plus 1. We're going to graph. Let me turn my screen down a little bit so you guys can see it. I hate fighting with this thing. Sorry, bear with me. All right, X to the third plus X plus 1. All right, so you can see this a little better. What does rational mean? What's rational mean? In general, what does rational mean? Oh my God, come on, guys. If you're a rational person or you're talking to a rational person, what's that? What do you mean? She said put together. What do y'all think? I'm okay with that definition. What does it mean? What does she mean put together? Yeah, reasonable. They make sense, right? What's irrational? They're like crazy. They don't make sense. Think about math. What numbers make sense to you?
Whole numbers.
Which ones don't? Everything
Fractions.
else, right? Does everybody understand that? So that's always how I equate it. Letters are not numbers. So how do I equate it? If we're looking for rational zeros, that means whole number zeros. So if we go back, sorry, my screen turned off. If we go back to this, what would it look like to have a rational zero? What would the graph have to look like to have a rational zero? What are zeros the same as? X-intercept. So what would rational be? Where's it going to cross? Well, it can cross at 0. Where else? Like 1, 2, 3, 4. It can't cross in between. So this one is doing what? That's why it doesn't have any. Did I see that? So if it crosses perfect, you'll know how many it has. So I'm going to show you a perfect one in just a minute. So look at this next one. This one is really crappy. Why? How many factors of 8 are there? Start with the littlest ones. Yeah, start in order. 1 and 8, what comes next? 2 and 4. There's nothing else, but what else could I do? -1 and -8, and how many different numbers do we have? 8 different numbers. Remember yesterday I showed you, I think it was yesterday, how to put it into y equals and plug a bunch in at the same time? You guys remember that? Let's do that. Okay. So I don't want you to have to sit here and plug in 1 and then plug in 8 and then plug in 2. So I'm going to write it down. F of 1. We're going to do f of 8. All this means is we're going to plug it in. F of 2. We're going to do f of 4. F of -1. F of -8. We're going to do f of -2 and f of -4. So we're going to do all of those at the exact same time because we're too lazy to do it by hand, and I'm okay with that. Everybody got it? So if you don't have your calculator, I would suggest that you go get it and learn how to do this real fast. Real fast. So that way, if you have any questions, I can clear those up now instead of answering 40,000 questions later. You want to put your function into y equals. So go ahead and put your function into y equals. Now, if you're using mine, your calculator will not stay on these settings because we've been changing them in Calc and in Math 1. So be ready for that. Okay. So you're going to put your function in. You're going to go to second window or your table set and change it to ask. So just the independent. Independent means X. So we want to tell it what to do for X. We don't want it to automatically generate it for us. You can, and you can scroll up and down in that table all you want to, but I feel like that just takes more time as well. So very good. So you can scroll your table if you want to, but I don't want to. So then when you go to your table, sorry, I hit graph and not table. When you go to your table, there may be some values in there. If you don't need them, just type over them. So in mine, there should be some, but we're going to type over it. So I'm going to do 1, 8, 2, 4, -1, -8, -2, and -4. Now you just write those down. F of 1 was 6, 8 was 216, 2, 4, and -1 were zeros. -8 was -840, -24, and -144. Is everybody good? You are more than welcome to do that in your notes. I mean, in your homework. That is fine. But again, we don't necessarily have to do that. And I'm going to show you why in just a minute. Now, how many zeros did you have? 3. So we have 3 possible rational zeros. What? I can't hear you. What did we just say? It has to be a whole number. Yep. So what would those whole numbers be? Which numbers gave us zeros? 2, 4, and -1, right? Check this out. Again, super long way to do it. But when I graph, what do you notice? They cross out. -1, 2, and 4. So I don't have to do all that stuff in my table. I can just look at it. So if they say list the possible, so like in your homework, when it says list the possible rationals, graph it and tell me how many cross at perfect points. Did anybody understand that?
Yes, ma'am.
That's literally all you have to do. So don't work yourself to death over it. So let's do the next one. And I'm not going to show everything. I'm just going to write it down. You already know how to put it in your calculator. What are your factors of -4? Start small. -1 and 4. -2 and 2. And one more step. -4 and 1. We don't flip -2 and 2 because they're the same factors. So we have a -1 and a 4. We have a -2 and a 2. We have a -4 and a +1. I have them in a different order over here, so they'll go in a different order when I write them down. So make sure you're watching. What? Yeah. F of -1 is -9. F of 4 is 116. F of -2 is -16. F of 2 is 24. F of -4 is -60. And F of 1 is 5. So what do you notice? There are no zeros, no rationals. So I'm gonna put it in my calculator so I can show you again, when you get this in your homework, put your function in, x to the third plus 2x squared plus 6x. Everybody good? And I graph this function. Does it go through any whole numbers? So you would automatically say none. Everybody got it? Everybody good? Claire, you good? You sure? Okay, don't lie to me. Everybody okay? All right, flip it over. All right, rational zero test with leading coefficient of 1. Find the rational zeros. You would do the same thing on this. We don't have to, we can use our calculator, but I'm gonna go ahead and show you anyway. Okay. So -6 would be what we would use. So what are our factors of -6? Keep going. Mhm. 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 So then what would I have to do? Mhm. Rational zeros test, what they would want you to do, here's another way to do it. Again, too much freaking work, too much work. But another way you can do it is take your factor and do synthetic division. If it's a 0, what's going to happen? Your remainder will be 0, right? So if it's a factor, your remainder will be 0. So we can try this one. 1x to the 4th, -1x to the 3rd, 1x squared, -3x, and -6. You would. Are we going to? No, I'm going to show you the first one. And then we're going to look at our calculator. Okay. So I just want you to remember why, because at some point they might ask you to divide and say, is it a factor? Use your calculator and determine that on your test. Use your calculator as much as you want to, but I've showed you how to do it by hand. Yes. -1 because this is your factor. Okay. Bring down your 1. Multiply by -1, you get plus -1 times -1 plus 1 is
3
times -1
3.
plus -3. It's -6 times -1 is, and we get, so we know that it has at least 1 because we got a 0. You would continue to do this multiple times. We're too lazy. We're not doing it. I don't want you to. So we're going to put it in our calculator. X to the 4th minus x to the 3rd plus x squared minus 3x minus 6. We're going to graph it, and you're going to tell me how many rational zeros there are. At least 2 right now, right? I would maybe zoom out and check to make sure there's no more graph, just in case they were kind of sneaky and its way over to the side. But remember, x to the 4th is supposed to be either U or W shaped. They should point up, so it shouldn't come back down. Does everybody understand that? Okay, so there are 2 rational. Make sure that they cross perfect. So let's do the last one, and we're going to do it like this in our calculator. X to the 3rd minus 15x squared plus 75x minus 125. Graph it. Hold on, sorry, Zoom 6 it. What do you notice?
I can think of that process.
That's why you should be doing it in your calculator too. What do you guys got? Don't care what it is. What do we want to know? One. If we did try to find it, it is 5. Do you remember what the other one was? We had -1 and, do y'all remember? Was it 2? It's going to be one of these factors, obviously, but I just didn't remember which one it was. All right. Using the rational zero test, also too dang long, but I'm going to show you. We're going to do the first one. I'm actually going to skip the second one. So you're going to do the factors of the constant. This is that P over Q that we saw in the beginning. Factors of the leading coefficient. And you'll learn why it's too long in just a second. Just a second. All right. What are your factors of your constant? What is your constant to begin with? 3. What are your factors? Mhm. What's your leading coefficient? Now this one's pretty small, right? So -1 and -2, 1 and 2. This is pretty small. These are real small numbers. Think about if you got a bigger number. Okay, this is what you have to do. Each factor of the constant needs to go over the factor of the leading coefficient. So here's what I'm talking about. We're going to start with 1. That's your first factor of your constant. You're going to put it over all 4 of these. So 1 over 1, 1 over 2, 1 over -1, and 1 over -2. So we got that one done. Now you have to do 3. 3 over 1, 3 over 2, 3 over -1, and 3 over -2. Now you have to do -1 and -3. -1 over 1, -1 over 2, -1 over -1, -1 over -2. And then do your last one, -3 over 1, -3 over 2, -3 over -1, and -3 over -2. Now, some of these are going to simplify to be the same, so we don't have to worry about those. But we do want to pick out each different factor. So 1 over 1 is what? 1. So we got that one. 1 over 2 is going to be 1/2. You can leave it as 1 over 2. 1 over -1 is, that's different than what we already have. 1 over -2 is -1/2. Start with your next one. 3 over 1 is 3. Then we have 3 over 2. That's a brand new one. 3 over -1 is, and then -3 over 2 is different as well. Now remember, this is a little one, right? 2 and 3 is super tiny numbers. All right. What about -1 over 1? We already have that one, so we don't have to worry about that. What's the next one? We already got that one. What's the next one? We already got that. What's the next one? We already got that up there. Next one. We got -3/2. We got 3. We've got, and +3/2. We've got. Then you would take all of those and do synthetic with them.
Synthetic with all 8 of those?
All of them.
Oh, yeah. So what that means-
But what I tell you,
Yeah.
what did I tell you? Right, because we have the capabilities using the calculator, we're definitely using the calculator. So everybody got it. But I wanted to show you by hand. So I'm going to do the first one just to show you by hand. 2, 3, -8, 3. And remember, I told you I was skipping the second one, so we're going to skip the next one. Bring down your 2 times 1 is 2, plus 3 is 5, times 1 is 5, minus 8 is -3, times 1 is -3, gives me a remainder of 0. What does that tell me? That 1 is 0, like, right? 1 is your answer. 1 is one of your answers. Does that make sense? So it will cross at 1. Now, you don't have to do synthetic with the rest of them. Let me tell you why. What does this end up being? Like when I started, I had x cubed. So what's this going to be? Keep going. And then what can I do to that? Slide and divide. When you slide and divide, you're going to get x plus 6/2 and x minus 1/2. So tell me what your other two zeros are, because remember, we only have 3. What's 6/2? Instead of positive, it's going to be, and that is rational. And then what about this one? It's factor of -1/2, so it's going to be positive 1/2. So it would not be rational, but those are your zeros. So you don't necessarily have to do all 8 of them like that, but if it were a huge function, you would want to narrow it down again and again. Okay. All right, again, we're going to skip this one and move on. It says find all the solutions of -10x to the third plus 15x squared plus 16x minus 12. All real solutions. That means whether it's positive, negative, decimals, fractions, it doesn't matter, but we don't want any i's, no imaginaries. So the first thing that I'm going to do is I'm going to be lazy. How many solutions should I have?
3.
I should have 3. How do I know if they're going to be real solutions using my calculator? Louder, I can't hear you. It goes through what? Yeah. So if it doesn't go through, I'll show you. Hold on, let me get it up there. If it goes through 3 times, there's 3 reals. Does everybody understand that? How many times does it go through? 3. So we're finding all 3 of those. If it only crossed twice, we're only looking for 2. What is wrong with the third one? It is imaginary. So we only want the real ones. Does everybody understand? Okay, so we're trying to find those 3. Can you find these on your calculator?
Yes.
Yes, you can. How do you find them on your calculator? Say it again. This one is y equals. I do a 0 in y2 and then do second trace intersect. Does everybody understand that? So you can do that 3 times. It's going to give you the decimal. So what you do if you don't have a calculator, or you don't remember that? Do I have any rational ones? Like any whole numbers that it crosses at? What are they? -1 and 2. So we know x equals -1 and x equals 2, but we got to find that third one. We got to find that third one. All right, so here's how we're going to do it. You're going to do the backwards box with your -1. Now, remember, you can do second trace intersect. So on your homework, do second trace intersect. I'll show you guys how to do that before we stop. I just want to show you how to do it like this. We've already done this. Remember when it asked you if it was a factor? Prove that it's a factor. It's the same thing. So we're going to do synthetic. We have a -10x cubed, a 15x squared, a 16x, and a -12. Bring down your -10. Multiply it. What do you get? Add it. Multiply it. What am I? Oh, I'm doing a different one. Sorry. Keep going. What? I think this is a positive too. I don't know why I wrote negative. 25, -25 plus 16. What happened here? What happened here? You told me you crossed at -1, didn't you? What should I get? So guess what?
You failed.
You did fail. It did not cross at -1. Where did it cross?
Close to it.
Don't erase it. Don't erase it. Just mark it out. You're fine. I did the same thing. I knew you were gonna fail. Where else?
I didn't fail it. I was just listening. to
Where else?
And didn't do the whole time.
Yeah, we looked at the graph and it does look like it
was all part of
crosses.
his plan.
Shh, shh, shh.
Yeah, when you go-
It does look like it crosses at -1, right? Okay, we'll talk about why it's different in a minute. All right, let's try 2. -10, 15, 16, -12. Bring down your -10 times 2 is -20 plus 15 is times 2 is plus 16 is times 2 is, and I got, what does that mean?
2 is a reaction.
The 2 is a rational one, so that is one of them. But I need to find the other 2. So there are 2 ways that I can do it. I have 10x squared minus 5x plus 6. How would I do this? You could try slide and divide, right? Probably not gonna work. Do you have factors of -60 that add to -5? What are they?
Like,
Do you know for sure? How else could I solve it if I can't slide and divide? What if I cannot factor it? We talked about it yesterday. Quadratic formula. Or complete the square. I'm too lazy to do all of that. Does everybody understand? So I told you before we finish this problem, I'll show you how to find the other ones. Can you do quadratic formula? Can you complete the square?
yeah,
Yeah, I've already taught you how to do that. What you want to do is in Y2, I put 0. If you do it a different way, it's perfectly fine. Do it your way. I don't care. That puts that red line across the x-axis, which means it crosses the red line now. So second trace intersect. I need to know this one. We thought it was -1. I'm going to enter 3 times, and it was actually -1.06. That's your second one. It didn't ask for rational this time. What did it ask for? All I did was, if you have a rational one, you can use it to find the other ones. But do you have to on your homework? No, just find them. If it specifies rational, what are you looking for? What are they?
0. Oh, hold on.
Whole numbers. So watch your directions. If your directions say list all the rationals, we only care about whole numbers. If it says list all real, what do we care about?
Everything.
Everything. Does everybody understand that? That's the only difference in what we're doing. All right, so then find your other one. You're gonna do second trace intersect again. And it's gonna be this one, so I'm getting close to it. Enter, and I get 0.56. 2 decimal places is plenty if you don't round it exactly right. So like if this was 0.565 and you gave me 5.6, I'm counting it. I don't have to see 0.57. I know that you did the work right. Is everybody good?
Yes.
What's wrong?
Second trace intersect and then
Yeah.
enter.
Zero.
Trace intersect and then enter 3 times.
Just 0. Yep. That's why I said do it in your calculator with me while I do it. Second, trace, and then we're looking for where they cross or their intersection. Now, every time you find one, you have to do that again. So if I went ahead and did enter, and found this one, and I wanted another one, I have to go back second, trace, intersect again. Okay, you can't just move it and enter a bunch of times. All right, so let's look at the next one. And the next one we're doing solely in the calculator. Next one solely in the calculator. So we have x to the third plus 4x squared minus 15x minus 18. I'm gonna keep that 0 in. If you guys keep that 0 in the calculator, it's not gonna hurt anything. Nobody cares. Okay, now it might go away from calculus to your class. It will not for math 1. So if they use them, you just have to put the 0 back, but it's not gonna hurt anything. Keep it in there the whole time. We're gonna graph it. Tell me how many zeros we have. How many real solutions do we have? 3. How many should we have? How many solutions should we have? So all of ours are real. There's nothing hiding. Does everybody understand that? To find them, second, trace, intersect. I always just start on the left, and let me tell you something quickly. If you'll hit up, it'll put it on that red line so it don't have to go through all the little humps. So if you'll hit up one time and then go to the left, it'll be a little bit easier. Enter, enter, enter. What's our first one? So we do it again, second, trace, intersect. I'm gonna hit up one time so it puts it on the red line. Enter, enter, enter. What do we get this time? -1. Second, trace, intersect. Again, hit up to put it on the red line. Enter, enter, enter. We got 3. That's it. Any questions? You can do that your whole homework time. That's perfectly fine. I don't expect you to do all the other stuff. It's too crazy. All right. What were conjugate pairs? Yep. So A plus BI and A minus BI. Complex zeros occur in conjugate pairs. All this is going to say, and I'm going to write all the blanks in, is if you have a factor of A plus BI, you're also going to have the factor of minus. Why? Because they come with square roots, right? When we take the square root, how many answers do we have? 2. One is positive, one is negative. So you can't have one without the other. Does everybody understand that? That's exactly what this little sentence is going to say right here. So let F be a polynomial function that has real coefficients. If A plus BI, where B doesn't equal 0 because that'll cancel out the I, is a 0 of the function, then your conjugate, A minus BI, is also a 0. You can't have one without the other. So in this next example, find a 4th degree polynomial. We're actually going to make the equation. We're going to make the function given our answers. You did this in math 3. You did not do it with I's. Okay, so that's the difference. So it says real coefficients that -1, -1, and 3i are the zeros. So this is what it means. When we solve it all down, we're going to get x equals -1 twice. That means multiplicity of 2. We're going to get that x equals 3i, but remember that that positive 3i cannot occur without a -3i. So let me ask you one more time. If it's 4th degree, how many answers should we have? How many do we have right now? 4. So everybody see that. That 4th one is the one they didn't give you because it should come together. All right.
And then, if it says what B does not equal 0, and it says it is also 0.
What?
It says it's a complex 0.
I got you. What about it?
A does not equal 0, and it says A minus BI is also 0.
All right. This can't equal 0 because it'll cancel out the I, and then it'll just be a number. That's all that's saying. All right. So how do I make this a factor? If x equals -1, what's my actual factor? Louder. Somebody said it. I heard it. Where do we have it? What's your answer to this problem? -2. Okay. So if your answer is -2, how can I take my answer and make it a factor? That's what I'm looking for. X plus 1. So what's your next factor? What's your next factor? X. What'd you say? Minus 3i, and your next one is? Perfect. We're gonna put them together.
X plus 1 squared.
You can, but we're actually gonna multiply them apart, like literally multiply them,
Oh.
literally multiply them. So what's X times X? So I'm gonna multiply these first, we'll come back to these. X squared, X times 1. That's a tough one. 1 times X. And then 1 times 1. Which simplifies down to what? So here's one of the factors again. Do the same thing on the next one, but what do we know about conjugates when we multiply them together? We only have to do the first and the last, the middle's gonna cancel out, perfect. So on this one, what's X times X? And then what's negative 3i times 3i? Negative 9i squared. What do we know about I squared? It's a sign changer, so this is actually X squared plus 9. Fun story, now we're gonna multiply those two together. So now we're multiplying these. Okay, so now we're gonna multiply these. So you're gonna distribute, I'm gonna distribute this way, X squared times X squared. Now, I write mine like an addition problem, so if you haven't seen that, you'll see it in just a second, just keeps it organized. X squared times 2x. X squared times 1. That one trips y'all up every time, but times 1. Distribute your 9. Here's what I'm talking about. 9 times X squared. I line it up with this like term. So that way it's like a straight addition problem. 9 times 2x. And 9 times 1. So then add your like terms. They're already in order. X to the 4th plus 2x to the 3rd plus 10x squared plus 18x plus 9 is your final function. The more factors you have, the worse the problem is, okay, multiplying wise. Look at your next one.
So when it tells you 3i, you have to put plus and minus 3i.
All right, so let's look at A. What are my factors? Okay, so X does equal 2, but what's my factor? X minus 2. And then? And then? But if I have X plus 7i, I should also have. Perfect. They just don't give it to you. It says find a 4th degree polynomial. I promise we're not going to sit here and do all of these. I just want to show you a couple. So that means we should have 4 factors, even though we only have 4 answers. So I'm going to do one of B and C, and then I'm going to skip one just because we haven't seen one with like the plus or minus in there. So this one looks exactly like what we just did. Multiply these. What do you notice about those? They're conjugates. So that means all I have to do is what? X times X. Negative 2 times 2. Negative 4. These are also conjugates. X times X. 7i times negative 7i. Negative 49i squared, and that is a sign changer, so positive 49. Is everybody good with that? Skipping that little step right there. Now multiply these together. X times X squared. X squared times 49. Negative 4 times X squared. And negative 4 times 49. Negative 196. Add your like terms. So your final answer X to the fourth, 49 minus 4 is 45, x squared minus 196. That one was not as bad because you had the conjugates. All right. I'm gonna do B with you. I'm gonna do B with you. If you need me to do C, I will do C. Okay. All right. So we know what our factors of 1 and 3 are going to be. So you're going to have the x minus 1, the x minus 3. The one that's going to confuse us right now is the x or the 4 minus I. All right, so let's work on that one first. So I'm just going to work on this one over here. We have x equals 4 minus I. I want to get it equal to 0. That's how we make a factor, is we get it equal to 0. So if you think about the other ones, if we had x equals 1, how do I get it equal to 0? Subtract 1. That's where the x minus 1 comes from. Does everybody understand that? So that's what I want to do here. How do I get it equal to 0? First thing I need to do. Move the 4, just like the 1. We're going to move the 4. Okay. What? You can, but that's going to make it complicated, right? Does everybody understand how that's going to make it complicated? Because then I'm going to have a lot of negatives that I don't want. What do we know about 4 minus I? If we have a 4 minus I, we should have what? 4 plus I. So actually, I don't need this negative at all. I can change this to the plus factor, which makes it a little bit simpler for you. Does everybody see that? I would always, listen, I would always use the positive one. It's going to be fine. And I'll tell you why in just a minute. What is I? How do I fix it? I'm going to square both sides. So now I have x minus 4 squared equals -1. I need to get it equal to 0 so I can move that 1 over, but I'm going to have to multiply it anyway. So you might as well just go ahead and multiply this out. The next thing you're going to do is multiply this out. What do we get? Multiply it for me. Good. Go ahead and put it together if you can do that. -4x and -4x makes -8x. And then -4 times -4 is +16. And then we have a -1. How do I get it equal to 0? So this is my other factor. So what you're going to do is you're going to take that answer of +1 and make it an x minus 1. The answer of +3 and make it a -3. And then this factor encompasses both the minus and the plus. So you don't have to work on the other one at all. Does everybody see that? Because if I factor it out, or if I complete the square, it's going to give me that. What happens right here when I take the square? When I fix this square, what happens? How do I fix it? How would I fix this square right here? Solving for x. Square root. How many answers are there to square root problems? So your positive and negative are built into this factor. So you only have to do 1, and I would do the positive every time. So that way you don't have to work with any negatives. Then you're going to multiply this by x squared minus 8x plus 17. I'm not making you multiply that all the way out. I'm not making you multiply it all the way out. When you finish, you're going to get x to the 4th minus 12x to the 3rd plus 52x squared minus 92x plus 51. When you multiply these, I would suggest that you multiply these first, and then you'll get a trinomial times a trinomial. You got to do all that crazy stuff. Okay. everybody okay with that? We're gonna work on this factor one more time. We have the positive, so that's the one I'd want to work with. If it has a negative in your book today, so in your questions, if it has a negative, we want to change it to a positive, okay? Use the positive one. So I only want to work on this factor. Look at your last one that we did. What was the first step? -3. I need to get it equal to 0, so I'm going to move the 3 first. So I get x minus 3 equals I. What is I? I want to get it equal to 0, so my problem is I have that square root. How do I get rid of the square root? So that gives me x minus 3 squared equals -1. What did I do next? Actually squared that out. X minus 3 times x minus 3 equals -1. When you multiply them out, you get x squared minus 6x plus 9 equals -1. And then how do I get it equal to 0? Add the 1, so we get plus 10 equals 0. That is one of your factors. What are your other 2 factors on this one, on C? X plus 1 and x minus 2, and I'm going to multiply by x squared minus 6x plus 10. When I multiply that all the way out, x to the 4th minus 7x to the 3rd plus 14x squared plus 2x minus 20. Okay. Every polynomial of degree n greater than 0 with real coefficients can be written as the product of linear and quadratic factors with real coefficients where the quadratic factors have no real zeros. We might push back our stuff. This is a long section. I didn't realize how long it was. Is everybody good? But you better hurry up, girl. I'll miss tons of time this stuff. Everybody good? You'll be fine.
I'm backwards.
You'll be fine.
I was carrying the team yesterday.
We will not finish this today.
Getting water, yes.
All right, guys. Shh. It says find all the zeros of a polynomial function x to the 4th minus 3x to the 3rd plus 6x squared plus 2x minus 60, given that 1 plus 3i is a 0. This is the same thing you did yesterday when they, bear with me, when they gave you like x plus 2 as a factor. Does everybody understand? Prove that x plus 2 is a 0 or x plus 2 is a factor. So how did we prove that it was a factor? What did we use? Synthetic division, right? So that's what we're going to do again. So the first thing that we need to do is get this into factor form. This is answer form. So we do what we just did. We always use the positive. How do we fix it? Subtract 1. What's different about this one? Okay, so I heard divide 3. Do I want to square fractions? So go ahead and square it at this point. Go ahead and square. Why can we go ahead and square it? Because we know that I is what? So if we'll go ahead and square this. On this side, we're going to get x squared minus 2x plus 1. What am I going to get on the other side? 9 I squared. And what is I squared? A sign changer. And then how do I solve it? add the 9. So we get x squared minus 2x plus 10 equals 0. If this is a factor, can I do that with synthetic division?
Yes.
No, I cannot. What can I do with synthetic division? What's been in my backwards box? Just what? Just a number, right? 1, right? This, guys. Let me explain something to you. There will be days, welcome to pre-cal, if you have calculus, that I'm going to teach all period. It will not carry over to the next day as a full teaching day. So I'm not going to let you leave here with 40 questions of homework or even 1 question of homework. Are we clear? Y'all understand what I'm telling you right now? Just bear with me the rest of the period. Stay focused and get through this. Listen to what I'm saying. This is your factor. Yesterday, when we were doing synthetic, we had factors like this, right? Can I do this in the backwards box in synthetic? No, this part cannot go in the backwards box. So we have to do long division.
We have to get the I gone and then we get whatever it is.
Yep. Now, if they give you a whole number factor, or they give you a fraction factor, not an imaginary, use synthetic. Okay, we can't on this one because we have this whole factor. So it's not going to be as long as you think it is, because remember I told you the longer that this part is, the shorter the top part.
So question, what is the I minus one? The X minus one?
Say what?
The X minus one?
I was just giving an example of what yesterday we had for the synthetic. That has nothing to do with the problem at all. What can I multiply that x squared to get x to the 4th? X squared. Multiply x squared times x squared. Come on, guys. X to the 4th. So I know I'm doing it right because it looks the same. X squared times negative 2x. Negative 2x to the 3rd. X squared times 10. How do I get them to cancel out? Change, change, change. Your x to the 4th cancel out. Tell me what I'm left with. Keep going. And then we're going to bring down our 2x. How do I make x squared look like negative x cubed? A negative x. That gives me negative x cubed. Negative x times negative 2 is positive 2x squared. Your numbers should match up. So x is x squared, x cubed. Negative x times 10 is negative 10x. How do I get them to cancel? Change, change, change. So your x cubed will cancel out. What's that leave me with? Bring down your negative 60. How can I make x squared look like negative 6? X squared. What kind of 6? Negative 6. So I get negative 6x squared plus 12x. Sorry, minus 60. How do I get them to cancel out? What do you notice? Okay, so it says find all the zeros. So how do I use this to find the rest of the zeros? What do I do to that thing? What are the factors of negative 6 that add to negative 1? Negative 3 and positive 2. So what are my other zeros? Louder. 3 and negative 2. How many zeros should I have had? 4. What were they? Clearly, 2 of them are. What are the other 2? 1 plus 3i and 1 minus 3i. Is everybody good? All right. The next one is the same way, but it's not as hard because it's just 4i and not 1 plus or 1 minus. So that one's a little bit easier. All right. So 4i is a 0. Remember, we're always going to use the positive one. So this one's good to go. What can I do with this one? Square it. I get x squared equals. Why is it negative 16? 4 squared is 16 and I squared is a sign changer, so negative 16. So what's your actual factor? X squared plus 16. Alright. Gotta do long division because it's not just x. If it were x plus 16, I could just do synthetic, but this one's not. Now, I showed you guys how to fill in the gaps. I'm going to show you how not to fill in the gaps. Now, this one, you're going to keep filling in the gaps if you have them. 3x to the third minus 2x squared plus 48x minus 32. What can I multiply by? X squared? That's okay. Don't worry about it. Don't worry about it. It's okay. Just draw an arrow up to it, and then when you get to the next one, write it in the gap that you didn't have. Don't erase it and do all the work again. How do I get x squared to look like 3x cubed? 3x. When you see that up there, you know that's a good sign because I'm not going to have a bunch of different ones. So remember, x is the one that we want, right? So that's the single, the little one. So we know it's not going to take long at all. 3x times x squared. 3x times 16. 48x, line it up. So what would go here? That would be a 0x squared. What do I do now? Change the sign. What happens? Cancels out. We have negative 2x squared. Don't forget that, okay? See that in there, negative 2x squared. Your 48s cancel, but I bring down my negative 32. How can I get x squared to look like negative 2x squared? Negative 2. That gives me negative 2x squared and negative 32. What happens? When you change the sign, they cancel out, gives a remainder of 0, right? All right. So if this is my factor, what is my solution? Positive 2 over 3. How many zeros should we have? 3. One of them is 2/3. What's the other one? Positive 4i and negative 4i. Everybody good? All right. So on the next one, all 4 of these are the same. We're not doing all 4 of them. I just want to show you how to start. So it says, write this as a product of linear factors and then list zeros. So it's all the factors and the zeros. It's what we did yesterday. Okay, it's the same thing, but we may have some imaginaries. That's the difference in what we've been doing. So how did I tell you to find your zeros in the first place? The easy way. Calculator, right? So let's do that. You don't have to do it. I'm going to do it in mine. You can look at mine. X to the 5th plus x to the 3rd. But if you want to do it, go ahead. 2x squared minus 12x plus 8. We're going to graph it. Tell me what you see. It looks like what? Looks like negative 2 and 1, right? You can check your table. Negative 2 and 1. Did it give us zeros? So we know it's right. Negative 2 and 1. But tell me what's happening at 1. It bounces. What does that mean? It's squared. So there's 2 of them, right? So it says write all the solutions or all the zeros. Your first one you told me was negative 2. And then you told me positive 1. But you told me it bounces, so that means it happens twice. How many solutions should we have? We should have 5. So I'm going to show you how to find this. All right. So now that we have singular solutions, we can do synthetic. We don't have these solutions, so we don't have to do long division. We can do synthetic with all of those. So remember how we did it, and then we took that bottom and did synthetic again, and then we are going to take that bottom and do synthetic again. Synthetic is quick, so don't be like, oh my God, it's too much work. It's real fast. So we're gonna push through this. So your first solution that I wrote up here was -2. That's what's gonna go in my box. That's where this -2 is coming from. Be careful across. I have 1x to the 5th. I have no x to the 4th, a 1x to the 3rd, 2x squared, a -12, and an 8. So just watch for that 0 in there. It's snuck in there. You're going to drop your 1 times -2. -2 plus 0 times -2 plus 1 times -2. -10 plus 2 times -2 plus -12 times -2. Should we have gotten 0? Yes. You don't have to do anything with those numbers except for make a new synthetic division. What was another answer that we got? 1. We're going to take these bottom numbers. 1, -2, 5, -8, 4. And we're going to do synthetic with them. So drop down the 1 times 1 is plus -2 is times 1 is plus 5 is times 1 is plus -8 is times 1 is. Should we have gotten 0? Yes, because it's an answer. We should have gotten 0. Then sometimes I get lazy and I'll just write my backwards box here. Your 0 doesn't count. Bring down your 1 times 1 is 1. Add that up, you get 0 times 1 is plus 4 is times 1 is. So we have a remainder of, what would I have left right here? X squared plus 4 equals 0. How do I solve that? Move the 4 over and then. So why didn't I see this answer on my graph? Because it's imaginary. How do you know? Because of the negative square root. So what are your final answers? We have a square root, so we're going to have plus or minus. What's the square root of 4? 2. How do I deal with that negative? There's your 5 solutions. So you use the ones you know to get the ones you don't know. Got it? All right. So we're going to stop here. We'll finish these notes tomorrow. You do not have any homework. We'll finish the notes. You can ask your questions on the last homework tomorrow as well. And then remember, I told you tomorrow is going to be a work day, right? Is everybody good? All right. No homework right now.